Hi everyone, myself Prishad, very warm welcome to all. And this is day 8 of Foundation AI series. And in this day, we are talking about like little bit concept around such a neural network and deep learning framework. So that's important part. And before going to just a second layer, before shifting to second layer of uh, such a, you can say particular playlist. And so this day we talk about like little bit concept around such as supervised learning, unsupervised learning, and token and fine tuning. And our third agenda is all about real world application. So this is agenda number one. And okay, so this is agenda number one, and this is agenda number two, and this is agenda number three. So I classify the full video into the three agenda. As we know, like supervised learning is important because of that. In this particular agenda, we are especially talking about like learning process, like how can we teach a machine to what the process, what the method to teaching a machine. Like with lots of method, reinforcement learning is also a part, but I try to explain you. I because of that reinforcement learning, I teach you reinforcement learning in the past video, but I today I will teach about little bit around supervised learning, and this is new method for training a model and teaching a model. Okay, so that's all about supervised learning. Okay, so second part is token and fine tuning. So we look toward the what is the token, what is the fine tuning also, and that's the important part also. Okay, so at the end we're talking real world application by connecting all these concepts like supervised learning, unsupervised learning, and token and fine tuning. So especially this term token refer to like we're talking about data. So this data is going to call that token. So this is a very small topic, and this is a basic topic and basic unit of the topic that you can say. And this is fine tuning also. And in fact, that's the interesting part of our particular model which we are want to train. So before making such as a strong architecture, so we need to create such a foundation layer. So that's all about for today. And nowadays the Google and the browser are like lots of search engine Google, and this is a Chrome, like Firefox. Now internet is available for all this particular thing, but I will teach you like to explaining this all this concept in such way like my own experience by adding my own expertise in this particular concept. So okay, so let's get started. Hey, let's come to agenda number one. And in this agenda number one is all about like supervised learning and unsupervised learning. So first we discuss what is supervised learning, and then after we move forward, like unsupervised. So supervised learning is all about, you can say, like teaching a machine from the example. Like in my definition, like teaching a machine from the example, sets of example, to how can they actually we are giving a machine to learn full process by giving input and output, both of them. So how actually they work, so let me discuss first. So supervised learning is all about teaching a machine from example, like we teaching a process, like finding process. Like now suppose you give an input and you give an output. Now machine try to learn what is the process to getting output, to just as walking toward the output. So what the process, so they look toward their process. Okay, look, so supervised learning is in fact one algorithm which is basically, you can say, designed for learning a machine from the pattern and like from example. So now suppose you giving a particular machine to, I can like lots of example here. Like now suppose your computer want to learn something like similar predicting dog image. Like you given an image, lots of animal image, they need to find out their dog image. But what can you do, like you give a input as a dog image, and the machine try to learn this particular image is dog or not, and they try to predict this dog or not. Like the actual output and input is available, but they try to predict it. Okay, so like it's all about like explaining the full process by giving an example. Like now you give it an example of dog, this is a dog, you say this is dog to machine. Okay, now some more your best example here, you're teaching your like you're teaching a kid to explaining that how the dog look like, how the elephant look like. Then you give an sets of example to just teaching the entire process. Okay, to understanding much better. So that's all about the supervised learning. So supervised learning is all about teaching a machine to uh, from sets of example is known as a supervised learning, and this is an algorithm. Okay, Okay, so let's come to their how actually they understand, like they need the for this particular requirement of the supervised learning. The supervised learning, the requirement is data, level data. In fact, level data in short, I will explain you like what kind of the level data is. So data labeling is all about like now suppose the best example is in contact, like you are calling someone. Okay, so you have a random numbers, but instead of remaining all the numbers, you try to just label all the numbers by names. Okay, you save the particular contact as name Ram, Syam, anything else like John and anything else, okay, by your contact. And that's how that data labeling work. Like some data you have in a data sets of data, but all the data is at level in such a way like uh, you can say in such a way like all data is a label in such a way like they name on some data, so that easy to understand to machine. So they learn all the things by data level data. uh, and output level, like what is actual output you already know, your machine actually know the what is actual output, but they try to predict and they analyze what is the basic difference between your predicted output and actual output. So looking toward differences, and they try to learn the entire process, and they become perfect according to it. So that's the entire process of the supervised learning in machine learning framework. So it's all about it. So in my language, my supervised learning is all about teaching a machine to like learning a process by giving example. Uh, one of the best example like mathematical example, you try you when you want to learn some concept. Okay, now suppose if you want to learn some concept, but you try with there some example. The first you try some example, and they you find out the patterns to solving a problem, then after you learn much better. So it's all about it. So that's really as it is happen in your particular machine also. The machine learns similar like this. So that's all about it. Okay, so the basically the supervised learning is basic use of the supervised learning is all about in classification. Okay, so the classification problem, now suppose cluster of image, you given a lots of image. Okay, but you want to teach a machine to just uh, like like classify the image, like dog, like finding predicting a dog image, okay, and cat image. Then this classification problem is basically lots of solve they're very important. Like now suppose your classification problem is solved by this kinds of the like algorithm like supervised learning. So classification problem is lot like spamming email is spam, to understanding the difference between spam and not spam. So when you're training a model, you use supervised learning to teaching a machine to understand difference between a spam and a not spam, to for making better prediction over the spam and not spam. So that's all about. So second part is like regression. So regression is all about predicting continuous numerical value, like something you can say regression problem is all about, you can say something like continuous value. For example, weather forecasting. So weather forecasting is like similar, you need to predict like loop, predict a particular weather in a loop, instead of like day 1, day 2, day 3, day 4, day 5, day 6, day 7, all this they continuously. So that kind of problem is actually solved by the particular thing, like you can say supervised learning algorithm is basically responsible for solving this kinds of the problem. So because of that, they learn the pattern much better. So that output is already given, input is already given, and lots of example. So that's all about supervised learning, and so that's all about the supervised learning. And in fact, you need to know about what is supervised learning. So the best way to understand supervised learning is all about teaching your algorithm, like teaching your machine to just learning from the example. Like you have lots of data sets, but you give an example sets of example to just teach a machine to learn. Okay, so that's the this basic process. Okay, so let's come to their agenda, like another part like unsupervised learning. Hey, let's come to the unsupervised learning, and this is a part of agenda number 1, but I will discuss in separately. So, uh, let's come to unsupervised learning. Like, what is unsupervised learning? So, in fact, unsupervised learning is, you can say, it is all about like learning, teaching a machine from unlabeled data. Like sometime you are not going to just teaching a machine for entire data sets, like this particular data refer to this and some ethics behind the data. So you given a random any data, and your particular computer want to understand, your particular system want to understand, like the try to find out the pattern. So it's all about it. So now suppose you get a sets of number, but they try to find out the particular spam, finding a pattern in this particular sets of data. Okay, so given a data sets, and in this data sets your particular machine try to find out the particular something, you can say like pattern to learn. Okay, so basically, so unsupervised learning is all about training a machine to such as unlabeled data. Like in short, unlabeled data refer to like huge data sets without meaning, like not any creating sense on there. So you are not giving a input and output like unsupervised learning. You are giving only for data sets, and the machine try to predict particular thing as well. So this algorithm is designed to just train a model from unlabeled data. And so what is the special like what is the basic, like what is the speciality of this particular unsupervised learning? So I think like the two speciality. The first one is like adapt learning from unlabeled data. Like you not teach a machine from scratch. The machine learn itself without such teaching from itself. They try to find out pattern insights, and they like update itself and just go all this stuff. So that's all about. So they adapt their adapt and learn from the unlabeled data. And second one is a flexibility. So this is a too much flexible, where to data shift, where what kind of pattern they learn. They shift anywhere, not at looking toward any random types. Okay, so that's about flexibility. So this were too much flexible, you can say. Okay, and so what are the key techniques of the unsupervised learning? As we know, like supervised learning is all about like data labeling. Like they teach machine from sets of example in any domain. Now suppose you are teaching machine to diagnose of this particular like medical patient, like cancer. Then you are teaching a machine to such a looking toward all this stuff, like giving example set. But in this particular, you have a huge data set, but machine by itself trying to find out the pattern. So what the key techniques are used to finding the entire data sets, to finding insights from there. So what are the key techniques? The key techniques here is like clustering. So clustering refer to like division of the data, classifying of the data. Now suppose you have in a data sets. Okay, now suppose lots of Gmail. Okay, and some Gmail is spam and some Gmail is not spam. Your machine itself try to just predicting and finding pattern between spam and not spam. So it's all like trying to find patterns in spam and not spam. So that's all about it. Like it sounds like similar, but the difference is like the machine itself try to find a pattern without any something like they grouping all this data. Now suppose spam and not spam. Okay, so entire group, like entire data set, they break down entire data sets in like clusters, different clusters, and find out the ethics and some kinds of the insights from the different cluster, and try to learn finding pattern which one is spam and not spam, and they predict and they update according to it. So that's the cluster process. And in this particular cluster process, like algorithm use like K means hierarchical cluster and DB scan. So DB scan just need to remember, but don't focus over there. This is all types of algorithm. It's basically designed for clustering data. Second thing, like dimensionality reduction, like all about now, like huge data sets, you need to focus on like for training a model, like your machine try to just focusing on few key principle. Now suppose you give it a data sets of the house prediction. Again, house prediction, like house price prediction. So in this house price prediction, the machine tried to understand by learning from the label data. Like inside in case unlabeled data, like they cluster it data, but they're looking toward the few key principles like locations. Okay, so the locations matter to just predicting a price, so that we only focus on entire data sets and only for location, not at like all the parameters. Okay, so that's all about it. Like dimensional reduction, like entire parameter, they not focus on entire parameter, they look a few principles like PCA is the best algorithm, principal compare analysis algorithm, which is basically designed for looking to entire data sets for few key principles, not an entire data set. So that's all about. Second thing, like association rule learning. So it's all about like combo relationship. So your machine try to find out combo relationship. Like for example, now suppose we taken a best example as uh, customer of the coffee shop. We have huge data sets of customer of coffee shop, but in this customer of coffee shop, the huge data sets, they find out the each customer demands, like what kind of demands of the customer. Now in winter, they look at the coffee. When the customer buy coffee, they also buy a sandwich also. So they cluster of like combo relationship. The machine try to understand that this is a combo relationship, and they understand this and they predict much better, and they learn much better about combo relationship. So it's all about like uh, teaching a machine for combo relationships. So this is an also technique, which a technique is used to just as unsupervised learning for combo relationship. And in fact is all about like if someone is buying coffee, they also buy sandwich also. So in this kinds of the season, so they predict also. So that's all about it. uh, so that's all about super unsupervised learning. And you just need to remember only for thing like unsupervised learning is all about like teaching machine, like machine teach itself by data sets, find cluster, association, and dimensional reduction. You can say anything process, any technique they itself apply to just learn from the data set. So let's come to agenda number 2 for this. Hey, let's come to agenda number 2, and in this agenda number 2 we are talking about like fine tuning and token. So what is the fine tuning and what is token? So let's start with fine tuning. So fine tuning is all about like adjustment of pre-trained model in the small data sets. Like for example, we can understand fine tuning in such a way like now suppose your model is trained to understanding analysis of like understanding analysis of, you can say, uh, image recognition, you can say, and you want to give in a spatiality, a spatiality of like different domain. Like you want to just train a model, like your model is working in like understanding the images and the predictor image, and image generation is all about your model is made for image generation. And you want to say that like this model is also capable, you want to make model to capable of like understanding medical diagnosis report. Then what can you do? So so the process is like the fine tuning says that like this other domain, you want to just adjust this other domain data sets in your model to fine tune. So that's the process is called fine tuning. So fine tuning is all about adjustment of the entire model in such a domain, in different domain, like pre-trained model, adjustment of pre-trained model in some domain is known as fine tuning. So fine tuning is work like similar. So fine tuning is all about process for adjusting adjust new domain in pre-trained model like ChatGPT. So ChatGPT is pre-trained model and it already trained. But you ChatGPT, if ChatGPT want to diagnose the health report, they need data sets. So fine tuning is all about like ChatGPT giving a data sets to learn other domains. So that is also called fine tuning. Okay, so that's called fine tuning. And the core approach of fine tuning is all about like you, the first stage, like we can say full fine tuning, like entire data set. If you want to teach a particular model to adjust learning like to different expertise, if you want to give a different expertise to a model, then I think like fine tuning is work here. Like something you need to adjust entire parameters, like entire weights, entire, you need to decide entire full fine tuning, like entire model parameters. Parameter refer to weight. Okay, you need to adjust all the weight of the model. Okay, so that's called the fine tuning, the full fine tuning. And full fine tuning is like very expensive and computational expensive. And So that's why this is not possible. Like if ChatGPT want to learn something new, then the first way they can follow is like fine tuning. They adjust entire model parameter. Okay, so that's it's very computational cost. They increase the computational cost, but some way, that is the first way, first method you can say, to do fine tune, uh, to full fine tuning. Second one is the PEFT. Okay, so PEFT method refer to partial fine tuning, that you can say. In this particular way, we train a model to partial, like not at all part. I take keep the all the part remaining same. Now suppose your model is capable for learning healthcare data and data, and you want to teach something different domain, like you can say something different domain, like you can say image recognition. uh, if you want to teach a machine to image recognition, like image generation, you can say image generation, this is a different domain. This is this one that you want to add different expertise to your model. Okay, so the first process they say that like you change entire parameter of the model, and that is the computational, that increase the computational cost. But instead of changing entire parameter, you can change few key parts. For example, like partial changes you need to adjust. Now suppose this second pass, the second approach says you need to adjust some partial part by all the remaining parts are the same. So that's all about, you can say, fine tuning process work. Like fine tuning process is all about either you full tune your full model, or sometime you need to reduce the model and just key change the partial change. Okay, do some partial change. So that's all about fine tuning. So fine tuning work like this. So the core approach is here is all about, instead of changing all the remaining data, you need to change some, need to adjust some parameter, and your model will work fine. So the first way is LoRa refer to low order rank adjustment. Like you in the parameter, like you need to change some teeny adjustment, not at very all, and then after your model learn, then after you change teeny adjustment. Okay, so that is a LoRa. Second is like QLoRa. QLoRa is also a part of the LoRa. QLoRa refer to you change the entire model parameter, but in the quantized manner. Like all this particular weight is such as in few bytes, not at very huge changes. Okay, so quantized LoRa matlab. Okay, so LoRa refer to lower order rank adjustment. So low order rank adjustment, teeny changes. Okay, in parameter you change your teeny things, like teeny changes. Okay, so understand much better. So that's all about the fine tuning. So fine tuning, in fact, the fine tuning is all about you can say fine tuning is all about, you can say, to adjusting some data sets in that pre-trained model. So it's all about fine tuning. So okay, so that's all about fine tuning. And the two method, partial change and full fine tuning. So this is a computational cost, heavy, it take heavy computational cost, and this one partial take adjustable. Okay, okay, so this is all about fine tuning. Let's come to their token. So what is the token? I will, this is a little bit concept that you should to know. Token concept refer to like when model want to learn something. Okay, so now suppose this is sentence like he is Ram. Okay, he is Ram. Now model want to understand this word. Okay, your chat GPT want to understand, your Gemini want to understand, or other AI model want to understand. They break down the entire word in token, like T1, and this is T2, and this is T3. Entire word in token, and they connect each word and understand much better. As we know, the self attention method, transformer architecture, we discussed already about this. So that's all about like token. Token is all about entire sentence breakdown in different units. Okay, so that's called the token. Okay, so that's all about token, and that's all about fine tuning. Let's come to agenda number 3, a real world application we understand much better. Hey, let's come to agenda number three. And in this agenda number three, we are talking about real world application of all this entire concept. I will connect this all this particular concept in this real world application to explain you much better, to experience you much better, and visualize you much better. So let's come to it. So in this real world application, basically the best example is supervised learning. So supervised learning is all about, we know that, learning from the live world data. So the best example, like image recognition. So image recognition is basically, we can use when we making image recognition app, then we can use this supervised learning. So algorithm to just teaching the difference between cat and dog pictures, so all about it. And unsupervised learning is like drug discovery refer to that discovering a medicine. When you want to try to make a medicine, then I think like the best example is like unsupervised learning, like but drug discovery, we need to just predict a protein structure. So lots of data around it, so lots of the huge billions of data sets. The machine try to learn itself by cluster and assumption rule, and you can say dimensional reduction. They try to understand much according to it. Okay, so drug discovery is the best example. And on this fine tuning, I take a just set of example. Now suppose fine tuning GPT-1. So GPT-1 is mad for such as LLM. This is a language model, and this is not mad for one such as coding. Okay, so coding. Okay, so GPT-1 is mad for LLM, and GPT-2 is mad for coding also. And LLM is also large language model, and basically it is mad for just browsing data only for like RAG. You can say RAG. It is only for RAG, it'll work here, but the retrieval augmented generation, it is basically all about like searching data from the website and reframe it and paying attention all this particular and give you a particular output. Okay. So GPT-1 is all about RAG, and GPT-2 is all about RAG plus coding. So in this is both model are talking about same, but after second version, the chat GPT, like OpenAI, adjusts the model data set. They give a new domain to they teach a new domain like coding. Okay, so that's all about the GPT-2. And GPT-2 learn much better about coding in such way like they can understand much coding around it. So that's how working at them. So that the entire process, like GPT-1 and GPT-2 is like GPT-1 have a RAG, and GPT-2 is all about like learn coding plus RAG also. So they adjust new data sets in their model. So they fine tune the model and they make such as after it like GPT-2. So that's all about real world application. And so that's how the real world application work. Fine tuning is important because when you launch your own app, that your AI model, you need to fine tune a full model. Uh, because of that, like you need to teach a model in different expertise. You want to give different expertise domain to understanding much better. So that's all about it. So uh, that's all about for today. And I try to give my 100% to explain you about my own expertise and my own knowledge and all about it. And again, if this particular video is going to productive for you, and if you learn something about that, then it's my pleasure. So thanks for watching and see you soon. Hi, hi everyone. Myself Krish, you can very warm welcome to all. And this is day 7 of Foundation AI series. So in this day we're talking about like a little bit around some basic concept we should to know. In this this is the this is the mathematical foundation concept, and in this neural network architecture, and lots of around it. But we are talking about somehow a little bit differences in this all these categories like weight, and you can say lots of topic about mathematical topic. So overall agenda for today is like the first we are going to discuss about weight and gradient. And weight and gradient, in fact the weight is very important part in this particular machine learning neural network in artificial intelligence. Like any system you are designing, weight is very important, and gradient is also important, and back propagation is just such an important part, and forward pass and backward pass, we should to talk about all this. And at the end, this is second agenda, this is third agenda. At real world example, we're talking about real world example much about like taking one such as real world application to experience these kinds of the concept much better. And I will try to connect this all this concept to explain you much better about all this particular concept. Like this is a mathematical concept, but I try to connect in this real world example. So that's all about for today. And okay, and so let's get started. Hey, let's come to agenda number one. And in this agenda, we are talking about like weight. So in this agenda, we are talking about weight and gradient also. But first part is our weight. So before understanding the weight, so let's come to understand weight. So before understanding weight, let me know you. Like I give you three word to understand weight much better. Like input, influence, output. So how much input influence output? So that is a weight. So weight is a scalar quantity, and it is a scaling factor. You can a flexible scaling factor which change according to importance. Now suppose for making, as we take like lots of example, but I think the best example is like house prediction. So in house prediction, we have three kinds of the parameter. Like the first one temperature, second one is the neighborhood, and third one is the footage, square footage. Okay, so how much input is important in such a making decision? Is it sometime this inputs like the three inputs, as we know, like three inputs. So we given as a weight. According to weight, we adjust the weight. So like suppose we given a specific number like integer, and you can say any kinds of number to each weights according to their importance. Now suppose if the location is very important in such as making predicting house, then you can say the weight scalar like weight is very high of this particular location. So according to parameter, according to inputs, the weight is a scaling factor, and this is a flexible scaling factor, and it change due to their one of specific use cases according to it. So that's the basic protocol, you can say. So that's how the particular thing is work. So in the case, weight is a scaling factor, and it is a flexible scaling factor. So it is all about a scaling factor, but it is flexible. In somehow it is too much flexible because it depend upon the use cases, like which factor is using more and which feature, which input is using more. So you can adjust weight according to it. So it is in a kind of the specific number and specific threshold. So it adjusts according to their a specific parameter, you can say, but it adjusts according to use cases. Okay, so in your definition, input, influence, output. Like input, how much the input is important to influencing output, like I will multiply. So in this full neural network architecture, when you predicting, so now suppose we can take an example like spam and not spam, then how much input multiplied by weight, this is a weight. Okay, and in this weight we can this the scaling, like you can say this magnitude of weight is increase and decrease due to the importance of the input. Like if this particular, now suppose this is location, this is the temperature, this is neighborhood, and this is one, you can say square footage. Then if the location matter much more in this neural network architecture, like predicting a house, then the weight is very high. So basically as we know, like the input it basically weight is basically classified in three category, like the three border category, as we know. Like the first one is positive weight, and second one is negative weight. So in the case of positive weight, now suppose positive weight refer to that very high magnitude. Now suppose as we know, like if this particular model predicting something a spam and not spam, then now suppose this feature matter more, location is matter more, like predicting spam and not spam, that I think like in the case you can think like something one digit of the Gmail is matter most. So you can take input and you can increase the weight magnitude in such way, like you can increase a too much weight magnitude. Okay, and that the particular thing happen, and so that's the positive input. So when making decision, so this positive weight participating more as compared from negative. So learning rate, as you can say, positive weight is much higher. Okay, second thing is negative weight. So negative weight is all about decreasing the process of the learning. So it's all about in this neural network architecture, this particular reduce the learning process of this particular goal. Now suppose if the input is, if we increase the importance of the inputs, like now suppose inputs, then I think like output will decrease. So it's all about, and near to zero sometime some kinds of the features not participating in decision. So we need to keep this particular near to zero, and ignoring such kinds of the features. Like now suppose in making predicting house, some kinds of features, you can say location, and you can say like temperature doesn't matter, and in that predicting house, so you can say we keep this particular value as a weight at 0. So it can adjust by, you can I can already say you I already said you uh, about this particular thing is like weight is just such as a scaling factor. So it adjusts according to the neural network framework. So machine can actually adjust a computer. Your computer can already adjust, your system can already adjust this all this thing. So that's the types of weight. And this near to zero and this full neural architecture work. And let's come to the three basic importance that we're looking for is like weight. So weight can change uh, by three factor, that I think like three factor is too much responsible for changing a weight, change weight. So in fact that's why. So the first one is learning rate, second one is input data self. For example, some input data is very high and the importance is very high, so you can say the weight is actually positive and the weight is very high of that particular data. Loss function, according to loss function, some data, some features is playing participating decision, but the loss is very high, like it's not sometime participating. So that's why the gradient and you can say architecture can decrease the particular flow of this weight, the value flow, and it's tend to be zero also. Learning rate is responsible because of the learning rate, sometime model learn, but they're not using this kinds of a decision, so that's why they can you can say that is not responsible for, and they decrease the rate and increase the rate according to learning rate. So increasing the learning rate, the weight can increase, but some features not at all. So that's all about it. As you know, the neural network architecture is all about like you can say uh, the weight. And in short, in my definition, weight is all about the importance of input in output. Like we need to adjust how can we teach a machine to just think like human, this particular input is important in such making decision or not. So this is an entire magic process. And you can think like this is a full architecture design in such a way, is all about like such a magic concept, you can say. And those who actually think like it is all about inspired by the human brain, and such a very important concept. And weight is important, okay. So weight is just a part which actually play an important role, like influencing input as output. So that's okay. So let's come to understand the gradient. Hey, let's come to understand about gradient. So what exactly gradient is. And so if we understand this gradient, the way to understand the gradient is all about shifting the direction for loss changes. Like now suppose our model is try to learn, okay. And if the model try to learn that they predict something, okay, they predict of something like, and they have a lots of problem. Like now suppose model want to learn but they predict something, but if they have some kinds of the differences in actual output and the predicted output, so this is the loss, okay. So their actual output and predicted output, the difference between them is loss. So that's loss, we need to fix this kinds of the loss. So for fixing for fix this kinds of the loss, we need to uh, use some kinds of the method is called backpropagation. And in this backpropagation, one specific term is used, basically used is your gradient. So what exactly gradient is? So gradient is all about giving a direction for loss changes, like reducing a loss. If you if the model want to reduce loss, okay, so gradients give a direction to loss. So it's all about scaling and vector. So it is scalar and scalar and vector quantity both. So it's all about vector factor, vector quantity, okay, with having a magnitude and direction also. So in this parabola, now suppose this is a loss function and the model want to learn something, okay. So initially this loss function is reduced, and sometime it this loss function want to reduce from this side. If you look this side, so the slope of this particular gradient, so that how much the rate, like where is the direction for the changing loss function. So if this particular function is moving this direction, then I think like this reducing the loss, okay. Okay, so reducing loss and the model learns want to again, okay. So the slope of gradient actually decide the how much the your model, your particular network architecture is capable for learning all this stuff, okay. So it's all about learning process, like giving a direction to shift the weight, okay. So now suppose your weight now suppose this particular input, so you can say understand in such way like now your input want to change, but your where to decide like where to shift the weight. So is it we need to increase the weight, or is we need to reduce the weight, or is we need to keep a value near to zero or ignore the weight. So who decide, and who given a vector and a scalar quantity, so about the increasing and magnitude. So I think like gradient is responsible for that, to giving us such as uh, you can say giving such a direction and magnitude of their particular thing. So I think that's in my opinion like gradient is all about giving a direction for a scalar and vector shift of their uh, your you can say it's all about giving a vector shift and scalar shift of the particular loss function, your weight. So your weight is basically it give a direction to increase or decrease your weight, and this is the based on the okay. So it's all about vector and scalar quantity, and you can say this is a factor of the scalar and vector. So okay, in fact that's in working way. So the key variation is all about the basically gradient is classified in three border category. Like the first one is the batch gradient, SGD gradient, and mini batch gradient. So in this batch gradient we look lots of things like uh, this gradient change by looking entire data set. Instead of looking one data set, they look toward the entire data set and take a decision where to shift a particular you can say weight. Okay, and this is called a batch gradient. Okay, in fact second one is the SGD gradient, and SGD gradient it take a training example, like looking toward the for lots of example, and they take a training example and find out their where to look. Okay, where to change a shape. For example, they predicted lots of prices of the house prediction. We can say in this house prediction they take a lots of example, but uh, take a lots of example, but one of them they pick one of them and decide where to shift. Okay, so random example they take and shift the weight according to the make decision. So other one is mini batch gradient, on you can say MBG, and MBG is referred to that mini batch gradient. And in this mini batch gradient we are this particular gradient actually decide by entire data set divided into such as mini batch. Like now suppose if you want a 4 data set, so now suppose entire data set, now suppose we can take full data sets. Okay, and we divide this all data sets in border category, and after this we can decide choosing one of them, randomly choose one of them, and fixing this all the issue, like deciding how to increase the weight or not. So that's all about it. So I think like the most fastest process is like this both are fastest process, but I think like batch gradient is fastest process, but they are slow, but both are slow. So you need to choose your own gradient method. So that's all about it. And gradient is all about, in fact gradient is all about vector and scalar unit. So it is a factor of the vector and scalar factor. So it is all about giving direction to where to change, where to shift a weight. Okay, so it's all about it. And it's create a confusion because of that back proposition sounds similar. So I will try to explain you such a difference between both of them. And if this okay, so let's come to agenda number 2 about back propagation. Hey, let's come to agenda number 2, and in this agenda number 2 we're going to discuss about like back propagation, and what is actually back propagation, and where is the use cases also. So let we discuss back propagation. So when we're going to discuss this back propagation, so I will give you such a magic word and a 3 magic words, so that I'll actually help you to understand much better. So back propagation work like predict, compare, and adjust. The full algorithm is designed, this is a method or this is algorithm, it's designed to just predict something. The predict, okay, now suppose your model predicting something, they calculate, compare, and calculate the loss, like they can calculate loss, loss in like actual output and predicted output, like looking between difference between actual output and predicted output. And then after they move toward the adjust, so it's all about adjust, they adjust all these parameters. So they adjust weight. Okay, what they calculate gradient. The calculation happen here is gradient. they move layer by layer. So it's a method or algorithm to moving layer by layer to calculate gradient and fix and adjust the weight. Sorry, I miss here. So to adjust a weight, so for adjusting a weight, so it's look like a method or algorithm. It is a method or algorithm to specially design to calculate moving layer by layer, like moving layer by layer to calculate gradient and fix and adjust weight. Okay, so it's all about adjust weight. In fact, that's the important point we should to note down. But in this lots of area, we can calculate or adjust weight in lots of things. Like the first one is forward pass. You need to understand this forward pass. So forward pass is all about input, hidden layer, and output. So it take a input, okay, and second one is the hidden layer, third one is output. So take input and move to the second layer by activation percentage. You know, input and weight multiply plus biases added, okay, bias added, and then move toward then main computation happen here and they predict output. Okay, after this process one more thing happen. One more thing happen is like backward pass. So backward pass is just reverse of this process. Okay, now they predicted something and the something they predict, and they look toward their actual output and their predicted output, like looking difference between all of them. Okay, so what the difference between all of them, they predict. Okay, then after they move backward, so they reverse the all entire process, and okay, that's fine. They reverse entire process and move toward their uh, computing part, like calculate gradient. So it is an algorithm which is especially designed for calculating gradient by backward pass. So it's move reverse process to just calculating gradient and know what is the fault, and they adjust the weight according to it. So it's all about, you can say, they predict and they look the difference between actual output and predicted out and calculate loss, and then after they shift the gradient in each layer by backward pass. Okay, and they adjust it the weight according to it. So that's my thing, that's all about it. So that's all about backpropagation. And backpropagation in simple term, you can understand the backpropagation in like predict, compare, and output. So this is the entire algorithm and method which is actually designed to such as solving this kinds of the problem, like calculating gradient. So gradient is all about unit, so scalar and vector unit, which is especially is in a magnitude or vector, like giving a direction or magnitude both. So it is itself and quantity, so which shows that how much does something need to change and some all this stuff. So that's all about it. And this is the entire process of backpropagation. And okay, so let's come to agenda number 3 for real world example and for experience much more about this real world application from this real world application. At the end, I always try to just take a real world application to understand much better about this all these concepts that we learn. So hey, let's come to agenda number 3, and in this agenda 3 we are talking about like real world application. So what kind of the real world application that is, basically I will connect this all the real world application to all this concept to explaining you much better to experience this kinds of the concept. So let's come. So on my learning journey, like basically this is one of the best example, and this is a magical example, you can say. Because of that, why I'm saying this is a best example. uh, Now this is the, you can say, this is on a changing, you can say, life of the human, and this is the this particular example show you like how actually uh, artificial intelligence create in a such as environment to the such as, you can say, can think like something, you can say artificial intelligence is a evolution, like is a participating evolution of the human, like living being. So it's example. So and one of my best example, and I inspired from this example too much because of that, that is best example from Google DeepMind. So Google DeepMind basically uh, is responsible for this particular example. I'm not going to sponsor this kinds of the example. In fact, the Google DeepMind actually Mac such as AlphaFold. So AlphaFold is a basically model which is actually designed for predicting uh, protein structure. So I think like for predicting protein structure, you should to know about, because of that this is very important, and this is a biological concept you should know, because uh, predicting protein structure for the scientists, like huge scientist team, like 50 people, 50 researchers, machines come together and take a 15 year to predict one molecular structure of the protein, one molecule sequence of amino acid. So it's all about like predicting amino acid structure, like valuable structure. So changing a protein structure, have an all different structure to right structure to choose uh, of the protein. Okay, and it take a 50 years. And the story behind it, like Google DeepMind solved this particular problem by CASP 15, I think like 15 16. Okay, CASP 15 16. So it solved this particular example, and because of that, the Google DeepMind is too much accurate and passionate about this particular problem, and Damis Chavez is the hero behind the scene. And I'm really too much excited about Damis Chavez, and you can just a huge fan of Damis Chavez. So that's all about it. And they predict a protein structure in such a way, like now suppose a gradient weight. So AlphaFold is all about like this is the amino acid sequence. We need to predict right protein structure to solve the problem. Like for example, when you discover a protein, when researcher want to discover, so it take a 50 year to predict one single molecular structure of the protein. Now Google DeepMind solved this particular problem, especially the my hero Demis Chavez solved this particular problem in such way, like they predict protein structure in I think like 100 to like 150 100, somehow they predict the protein structure in such as few seconds after making a alpha fold. You can't imagine like 15 years problem, like it take a long timeline to solve the particular problem, when like 50 years long timeline to researcher to continuous work consistently to one single structure. And Google DeepMind solve this particular problem in such as few seconds. So that's the interesting one. And you can say this is responsible for that 50 years to take a one problem solving. And how actually what the biology behind it, so I will explain you. Now suppose this is a protein of coronavirus, so we need to hold a protein in such way to find the antibiotic to coronavirus. So this is amino acid sequence, and we need to predict, arrange this right structure to predict a protein structure. So it's all about it. And that's AlphaFold is responsible for. And this is a great work of Demis Hassabis, and so that's why I am too much excited about this discovery. And this discovery is one of the best scientific research all over in the party in this world, showing the power of artificial intelligence, how artificial intelligence just changed the all over the world after in coming in the full potential. So come in the full potential. So that. So let's come to their input, and this one the hidden layer and output. So let me understand this how actually our concept works behind this particular architecture. So basically it's all about Google DeepMind discuss it, and I want to explain you, like this one is input layer, hidden layer, and output layer. So now suppose they give us some kinds of the protein structure, and this protein structure amino acid sequence. This amino acid sequence is converted in input layer as a node and different kinds of neurons. And after this neuron, this hidden layer, and second one is the output layer, is the predict right protein. Okay, they do mixed tech. Okay, so where is the weight? What is weight? Where is the weight used here? So weight is used here like amino acid sequence. We need to look like right structure. Like now suppose this is amino acids, we need to decode DNA. Now suppose DNA is here. Okay, in the protein we have now suppose DNA. So each DNA part, we can take each DNA part as input, and we multiply with weight. So weight is work here as in the sequence, as you can say they look toward the all input part. Okay, so in right way, so look toward their uh, each input parts as your inputs, like how much inputs parts participating in right structure. So that's the workflow of the weight. Second one is gradient. So gradient, where is the gradient? As you know, gradient is as a scalar and vector quantity only for. Okay, so now suppose model predicts some structure. Now suppose this. Okay, but our structure is like this. There how much difference between this one predicted architect product, like predicted output, and actual output. Like they look the differences between them and calculate loss. Okay. And okay, so they move the backward pass. The process happen like backward pass. Okay, so backward pass, the first, if the moving particular thing is from this side to left to right, then you can the forward pass, and right to left, then backward pass. So then process the backward pass happen, and they look toward the losses, and they calculate the gradient by back propagation method. So back propagation algorithm is designed to calculate layer by layer all this gradient. Like gradient is all about quantity, like vector and scalar quantity, which is responsible for. So that's how they calculate this all the gradient, and reduce the loss. Okay, so that's the particular back propagation work. And so that's how this actually gradient weight back propagation work. But in fact, if you're looking toward the more excited example, as AlphaGo is the best example, actually discovered by the Google DeepMind. And Google DeepMind is responsible for lots of scientific discovery, but in future they are working on quantum computer and lots of example. But I think like that is exciting time for now, to just as entrepreneurship and lots of things. But I want to say that like this one is the important part to just looking toward this. And AlphaFold is the best example for protein structure, predicting protein structure. And that's all about. Okay, so if this particular video is going to productive for you, and if you learn something for that, then it's my pleasure. So let's get see you soon.